Welcome back, everybody. Today we're going to be talking about polynomials, how to classify them, and some examples of what are polynomials. First, let's look at how to classify by degree. Now, when we say degree, we mean by the highest exponent. And an exponent could be 1. And whenever the highest exponent is 1, we call that a linear term. And then an example could be 2x plus 3. Notice how the highest exponent here is a 1 on this variable. If we have the highest degree is 2, we call that a quadratic. Example of a quadratic: x squared plus 2x minus 1. The highest exponent here is a 2. You could have a highest exponent be 3, and you call that cubic polynomial. Here's an example of a cubic polynomial: 4x to the third. And then finally, you could have a degree of 4, known as quartic. And quartic example, negative 5x to the fourth plus 2x. Now that's by classifying by the highest exponent, known as the degree. You could have more. You could have a 5th degree, 6th degree, and there are prefixes for those, but usually is said polynomial of degree 5, degree 6, etc. Now let's classify by the number of terms. Let's say you just have one term. That would be known as a monomial. Example of that, 2x, just plain old 2x. Say you have two terms. That would be known as a binomial, prefix bi meaning 2. 3x minus 4, a binomial example. Say you have 3 terms. That would be known as a trinomial. X squared plus x plus 1 is an example of a trinomial. And you could have 4 or more terms, and after 4 or more, they usually just call it poly, meaning many, polynomial. (2x cubed minus 3x squared plus 4x plus 9. Example of a polynomial with 4 or more terms. And then you put them together. So let me kind of revisit all the 8 examples and call them by both the degree and the number of terms. This would be a linear binomial, quadratic trinomial, cubic monomial, quartic binomial. This would be a linear monomial, linear binomial, quadratic trinomial, cubic polynomial. All right, let's look at a couple examples which just describe polynomials. Now, it turns out for a full polynomial, not allowed to have radical symbols and negative exponents. Otherwise, you can't call it a true polynomial. So no radicals allowed, no negative exponents allowed. That would mean C wouldn't work, D wouldn't work. Notice we have our radical symbol, we have our negative exponent. A can be considered a polynomial, so could B. Classifying it, A would be a quadratic monomial, B would be linear binomial. And sometimes it can be rewritten. We could rewrite x over 5 as 1/5 x plus 2. And then we see the highest exponent is a 1, 2 terms saying linear binomial. But A and B are the polynomials. Let's look at another example here. Remember, no square roots allowed and no negative exponents. So that would mean x minus 1 works, x plus p works, 8x minus x to the third work. Classifying these, linear binomial, cubic binomial. Now let's give you an example and just classify what we see. Negative 5x squared minus 3x plus 3 Quadratic, because the highest exponent is 2, 1, 2, 3 terms, make this a quadratic trinomial. Quadratic trinomial is the right answer here. 3 terms for trinomial, and the quadratic has a highest exponent of 2. Let's classify this one. Trinomial again, 1, 2, 3 terms, so it's either A or D. The highest exponent is a 3. That tells us it's a cubic trinomial. All right, and lastly, this last example here, a little bit different. Sometimes we have different variables, and yet they're still considered polynomials. What you want to do is kind of look at them as a cluster. Look at this first cluster of variables, and look at this second one. Let's focus on the second one. The highest exponent is a 2. Look at the first one, though. Look at each of the exponents on 3 different variables. We have an A, a B, and a C. A to the 1 power, B to the 1 power, C to the 1 power. When you have different variables, add up each of the individual exponents. So it's either A to the 1, B to the 1, C to the 1. Technically, it's like to the 3rd power because we have 3 quantities being multiplied that many times. I just added up 1, 1, and 1 to get 3. This 3 here tells us that's the degree of our polynomial. When you have different variables, look at them as clusters and then add up the individual exponents to find the true degree. It's not 2. This one is actually a degree of 3. All right, thank you for watching. Hope this helped.